Today, we're going to learn about manipulating systems of equations. In this lesson, we'll explore how to rearrange, multiply, or divide equations to make them easier to solve, and then apply either substitution or elimination to find the solution. When you solve a system of equations, sometimes it's easier to first manipulate the equations to make the math simpler. We can do so by moving terms around to isolate variables or group them in a way that makes the problem easier to solve. It's useful to multiply or divide both sides of an equation by a number to make the coefficients of one variable the same in both equations to eliminate one variable and solve for the other. After manipulating the equations, you can use either the substitution or elimination method to solve the system. Let's look at each of these strategies in action. Let's solve the following system of equations. We should first notice that by dividing the second equation by -2, we can get -4x, which is the opposite of 4x in the first equation. Now that we have -4x in the second equation and 4x in the first, we can sum the two equations to eliminate x. Now, let's simplify our equation. Finally, we divide both sides by 4. By dividing the second equation and summing the two, we easily eliminated x and solved for y. Now that we know that y is 2, let's substitute this value back into one of the original equations to solve for x. Then, we simplify our equation. Finally, we divide both sides by 4. We can see here that the final value of x is 3. Another way to solve this would have been to eliminate y instead of x. We could multiply both equations so that the coefficients of y become opposites. Now, we can use these two new equations to eliminate y and solve for x. First, let's add the equations together. Now, let's simplify. Finally, we divide by -32. This method works too, but the first method of dividing by -2 was much simpler because the coefficients of x were already divisible. To conclude, the solution to the system of equations is x equals 3 and y equals 2. By noticing that dividing the second equation by -2 made elimination much easier, we avoided more complex steps. This is why it's important to look for opportunities to simplify equations early in the process. Let's look at another example. Let's solve the following system of equations using substitution. We notice that the first equation contains a fraction. To simplify our calculations, we can multiply the entire first equation by 2 to eliminate the fraction. This will make the substitution process easier. Now that we have the simpler equation, we can solve for x. This will allow us to substitute this expression for x into the second equation. Let's now substitute this expression into the second equation to eliminate x. Now, we distribute 3. Then, we combine like terms to solve for y. Finally, we divide both sides by 10. Now that we know the value of y, we can substitute this value back into the equation to find x. Next, we simplify the fraction. Then, we convert 8 into fraction. We can see that the final value of x is 24/5. To conclude, the solution to the system of equations is x equals 24/5 and y equals 8/5. Great job! Let's try one last problem. Let's take a look at this problem. In this problem, we need to set up and solve a system of equations based on the constraints of assembly and testing hours. Let's solve it step by step. Let's start by defining our variables. Let x represent the number of machines of type A produced, and y represent the number of machines of type B produced. Now, we'll set up two equations based on the constraints of the assembly and testing hours. The first equation comes from the total assembly hours. This means each machine A takes 3 hours of assembly, and each machine B takes 5 hours, for a total of 36 hours of assembly. The second equation comes from the total testing hours. This means each machine A takes 2 hours of testing, and each machine B takes 4 hours, for a total of 28 hours of testing. We will use the elimination method to solve this system. To do this, we first need to manipulate the equations to have the same coefficients for one of the variables. Let's eliminate x by multiplying the first equation by 2 and the second equation by 3, so the coefficients of x will match. Now that the coefficients of x are the same, we can subtract the two equations to eliminate x. Let's subtract the second equation from the first. Then, we simplify. Now, divide both sides by -2. Now that we know y is 6, let's substitute this value back into one of the original equations to solve for x. Let's use the first equation. Next, we simplify. After that, we subtract 30 from both sides. Finally, we divide both sides by 3. From here, we can see that x is 2, and y is 6, meaning the factory can produce 2 machines of type A and 6 machines of type B. To verify, substitute these values into the second equation. The total testing hours check out. Among the choices, we can see that the correct answer is choice B. By aligning the coefficients through multiplication and using elimination, we solved this problem. Great job today! Let's quickly recap the key strategies we learned for manipulating and solving systems of equations. Sometimes, it's necessary to rearrange an equation to isolate a variable. This helps set up for substitution or makes elimination easier. We saw how multiplying or dividing both sides of an equation can help align coefficients, making it easier to eliminate one variable. By solving one equation for one variable and substituting it into the other equation, we can reduce the system to a single variable equation and solve step by step. We use the elimination method by manipulating the coefficients to eliminate one variable, leading us to the solution of the system. By applying these strategies, you'll be able to confidently manipulate and solve systems of equations. Keep practicing, and soon, these problems will become easier.